Alright, so yesterday we talked about the arithmetic sequences, and so we found that the a sub n you can find by doing dn, which is the d is the thing you're adding or subtracting, and then plus the a naught, which is the first term. So today we're going to just do a little bit of a twist on that. So this time we're going to know the fourth term, which is 20, and the 13th term, which is 65. And I do need to tell you it's an arithmetic sequence or you won't be able to do the problem. Alright, so if we have the 13th term and the 4th term, we know we have 65 minus 20, so we know we have 45 numbers that we need to cover. And we're going to be adding the same thing every time. And we know 13 minus 4, that we have 9 terms to do it in. So 45 over 9 gives us 5. So every time we go up by 5. So that's our D. So we know AN is equal to 5N plus A0. So to get the 0, I know that if I put in a 4 for my N, based on this, my answer should be 20. So this is how you solve for A sub 0. So we end up with 20 equals 20 plus A0. So if you subtract the 20 over, you figure out A0 is 0. So we end up with just A sub n equals 5n plus 0, but I don't need to write that. Okay, so you guys try this one. So pause it here and go ahead and try where you have A6 equals negative 38 and A11 is negative 73, and again you have an arithmetic sequence. Okay, so go ahead and pause here and try. Alright, so this is what you should have ended up with. So we figure out what the D is by subtracting the terms and then dividing. So you know your D is negative 7. And then you plug in the 6 for the N, where you know your answer should be negative 38. And then you solve for A0. Alright, so that's one type that you'll have to do that's a little bit harder than what we did on Monday. So let's move on to one where you might need to do it with the recursive. So with the recursive, you're given the A1 term, and then they'll give you the recursive form. So this is basically just telling you to take the new terms and subtract 2.5 every time. So if it's in this format, this is telling you your D. So we're trying to write the A sub n. So I know that my D is negative 2.5. I do my N, and then again I need my A0. So I know if I plug in 1 for my N, I should end up with 1.5. So you can solve for A0 here, and you can figure out if you add the 2.5 over, you end up with a 4. So your A sub n equation will be negative 2.5n plus 4. So that's how you can turn a recursive into an A sub n equation. So that is the end of how to write the equations for arithmetic. Now let's talk about sums. So sums of arithmetic sequences. So the formula we're going to use, so the sum of any particular sum of certain numbers, is you take how many numbers you're adding, divide by 2, and then you multiply by the first term and the last term. So let's just go ahead and try one. So let's say that we have a sequence that's 6, 11, 16, and 21, and so on. And I want to find the 7th partial sum. So your first step will to figure out what the pattern is. So if you look here, we've got a pattern where we're adding 5 every time. So we do know our D is 5. Okay, so we need to figure out what our A sub n is. So we know A sub n is equal to 5n plus A0. So if you go backwards from the 6 to get the 0 term, you know that your 0 term is going to be 1. Okay, so there's your A sub n. So we're finding the 7th partial sum. So to get the 7th partial sum, we know we're adding 7 numbers. We divide that by 2, so that's just the equation I'm using from above. And then the first term in the pattern is 6. And then I need the 7th term. So my A7. So to get that, we are going to go ahead and do 5 times 7 plus 1, which will give us 36 for the 7th term. So without having to actually find all 7 terms, we use this little shortcut. So we just multiply that out in our calculator, and you get a sum of 147. All right, so just doing some more of these. So now we're going to go the sum of the first 100 positive odd integers. Okay, so I know I'm doing a sum of 100 total. So I know I'm doing 100 numbers divided by 2, so I got to figure out the first positive odd integer and the 100th positive odd integer. So I do know that if I'm going up by odd integers, I'm going to start by adding 2 to go up an odd every time. And if my first odd integer is 1, then going backwards would be a minus 1. So the first odd integer is just 1, and the 100th odd integer would be if you plug 100 in here, so you get 199. So that's your 100th odd integer. 100 divided by 2 is 50. Multiply all of that out, and you get 10,000 for your sum. So this is just shortcuts because it's going to be a pain in the butt to have to add 100 numbers all together. Alright, we'll try one more. So you also could get this stuff in sigma notation. So you've got an n, where we start at 51 and we go to 100. And then I'm going to do a summation where I start at 1 and go to 50. And again, I'm doing n. So remember, when you plug in that n, you go 51, and then you would have a 52, and then you would have a 53 that you plug in for n, and that's all you get, and you do it till you get to 100. I'm doing it over here. I start by plugging in 1, then I plug in 2, then I plug in 3, and so on until I get to 50. So do you see how you really just have an arithmetic sequence that you're going up by 1 each time? So what's going on here? We've got an arithmetic sequence, 51 to 100. How many numbers actually is that? It's a difference of 49, but if you include the 51, it's 51, 52, and so on. That's actually 50 total numbers, so that's an important thing to note. And then our first thing is 51 that we get, and then the last thing when you plug in the 100, 100. And then over here, 1 to 50, that's 50 numbers. Because again, we're including the 1. The first thing in this pattern is 1, and the last thing in this pattern is 50. And again, you have to make sure that it is an arithmetic sequence in order to use the equation. So if we simplify that guy, so we have that for that total, and 1275 for this total, and you get 2500 for your total sum. So I do want to point out one more thing, just with how many numbers you're adding. So like if we had started out at 50 and gone to 100, that's actually a total of 51 numbers. So it's kind of, you do the subtraction but then add one, because you got to include where you're starting as a count in the total numbers that you have. So you have to be a little bit careful when you're figuring out what the numbers are to put in for your n. Alright, so those are the notes for today, so you guys can work on your homework now.